Hey, I wanted to take an opportunity to discuss with you guys about how the core affects the amount of inductance that's being produced by an inductor. Okay, so if you have an iron core in an inductor and you were to remove that iron core and replace it with an air core, how would that affect the amount of inductance that is being created by that inductor? So I want to take a moment to show you how that is impacted using our inductance formula. So the formula L for inductance equals number of turns squared, okay, times permeability. That symbol is for permeability. Permeability is the ability of a material to support lines of flux. So number of turns times permeability times length of the conductor. So that is the number of turns of wire on the core, so the coil, right? So the longer the conductor, the more turns, okay? So all of those components are considered to be directly proportional to the amount of inductance that is being created, okay? The formula is then divided by D, and D is the distance of the armature when it's sealed as opposed to it not being sealed. So when you have maximum magnetic field being produced by your inductor, the distance between your armature is minimal, okay? So the distance of the plate or the distance between the armature is indirectly proportional to inductance, okay? So back to replacing the core, if I originally had an iron core, removed it, replaced it with an air core, how would that affect the amount of permeability? So an iron core has a higher permeability than an air core would, okay? So that means if I were to take the iron core and replace it with an air core, my permeability would go down, okay? And if permeability goes down, then inductance goes down proportionally. Okay, so hopefully that helps a little bit with the understanding of this formula and how it pertains to the amount of inductance that's being produced. So there is a question on your module test for inductance and inductive reactance, and it is, what is the inductive reactance? So what is the XL of a pure inductor? So what is the XL, the inductive reactance of a pure inductor in a circuit, okay, where current flow is 1.089 amps, okay, and our supply voltage is 120 volts, okay? So I just want you to be aware that it's important that you recognize what pure inductance or a pure inductor means. So if an inductor is stated to be pure, it means it has no variables of resistance contained within it, and it means that the circuit has no capacitors in it, okay? So if you have a circuit that contains only a pure inductor, I want you to be aware that whatever your XL, your inductive reactance is, will equal your impedance. Impedance is the total opposition to current flow in an AC circuit. Okay, so based on this information, I can solve the amount of XL, being that this inductor is stated as being pure. Okay, so I can use the Ohm's law formula. I total equals E total over Z. Okay. Because it's a pure inductor and we stated XL equals Z, I can transpose this Ohm's law formula to figure out what my XL is, okay? So I have to cross multiply here to bring everything into direct proportion, okay? So I times XL equals supply voltage. I want to get XL on its own, so I would divide by I. What I do on one side, I do on the other. Okay, so XL equals supply voltage divided by current. So supply voltage is 120 volts. Divide that by the 1.089 amps. Okay.